All right, so now we want to talk about something called moraines. Moraines are piles of sediment. Remember we just said that weathering carves these valleys, weathering leaves these ridges and all these other shapes, but it's moving sediment out of the way as it's doing that. We told you that sediment is going downhill, down glacier, whatever you want to say. And I told you that it comes out where it's melting. Well, it also comes out at the sides once you come down into the lowlands. It can melt out of the sides of the glacier as well. And these moraines are what we call that sediment that accumulates along the sides of the glaciers and in front of the glaciers. Okay? And we really just have, I don't know, 7, 8 flavors. Let's see. 1, 2, 3, 4, 5, 6. Yeah, 6 different moraines that you need to keep straight, okay? All right. So, the first is a lateral moraine. A lateral moraine is a moraine that forms along the side of a glacier. Okay, lateral. Forms along the side. Again, it's sediment that piles up while the glacier is melting out along the sides. All right. A medial moraine is a lateral moraine that happens to now be in the middle of 2 glaciers. One came first, one came second. It's hard to tell here. But and over here is kind of an exaggeration for educational purposes, I suppose. But in between each of these glacial flows, they've got a lateral moraine forming. Any lateral moraine that is in between 2 glaciers is a medial moraine, okay? So this is a medial, 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 even though it's not pointing to all of those. It's got to be on the complete outside to be just a lateral moraine. You follow? So on the end here, all the way over to here, laterals. Medial, medial, medial. Here's a lateral, but that's a medial. You dig? All right. Good, because now it's going to get even more confusing. We're going to jump down to the end of the glacier. Remember, the end of the glacier is called the terminus. All right. And what we have in front of the bottom of the glacier, in front of the terminus, we call an end moraine. Why? Because it's at the end of the glacier. All right. However, we've got 2 kinds of end moraines. We've got a terminal moraine and a recessional moraine. Bear with me here. Terminal moraine is going to be your last end moraine. Your last end moraine. Okay? In other words, as far as you can tell, this is where the glacier used to be. Then it melted back, stayed there for a while, left a pile of here. Then it melted back some more, stayed there for a while, left a pile here. So each one of these was an end moraine, but this is a special name for the last end moraine called a terminal moraine. Now, any moraine, let me rephrase that, any end moraine behind the terminal moraine is a recessional moraine. It's showing recession. So if you were looking at this from above, you could look down and say, oh, this glacier is receding. How do you know that? Well, you see 3 end moraines. If it was growing, it would smash right through all those, right? All right. So end moraines are at the bottom. Lateral moraines are along the side. If you got a lateral moraine in the middle, you call it a medial moraine. Your last end moraine is a terminal moraine. Any moraine behind that is a recessional moraine. All right. There's one last word I haven't covered here. Ground moraine. A ground moraine is when the glacier isn't in one place long enough to actually build up a pile. With this, I always use the, and I don't know if people even still do this, you know those little things you push around your yard when you want to plant grass seed or put fertilizer out? Okay. It's got the little spinny thing on the bottom, and as long as you walk, it spins and it throws grass seed or fertilizer wherever you want to, right? You know what I'm talking about? All right, picture one of those that was automatic though, okay? That little thing spins no matter whether or not you're walking or standing still, it just keeps spinning, motorized. So let's say you turn it on and you start walking and you're going back and forth making your nice even rows. And then your neighbor comes over and starts chit-chatting with you and you forget it's on and you sit there for 3 minutes. The whole time it's throwing out seed. Well, when you're sitting still, it's going to build up a pile of seed in that area, right? That's these moraines, the lateral, the whatever, the terminal, the ground. That's these ridges. But when you're walking nice and steady and it's just throwing out one layer, if you would, of seed, that's what this ground moraine is. It's just a steady deposit. It's not very thick, but it's definitely there. So, you know, you could have a much wider area being called ground moraine. You've just got a little bit of riffraff in between each of these that could be called ground moraine. Okay. This arrow is ill pointed. I think it should either go there or there, but nonetheless, it seems to be pointing to exactly where they have ground moraine in the previous slide there. So, ground moraine, at any rate, is a sheet-like covering of sediment, whereas every other kind of moraine is a ridge, a pile. Okay. All right, it's a lot of vocab, and they're all very similar. I try to, again, simplify it with my little slug diagrams here. All right, so let's try to remember some of our words here. We've got lateral moraine. Where's our lateral moraine at? Well, we said lateral moraines along the side, right? So let's say Z here. These are lateral moraines because they're along the side. Well, what do we call those lateral moraines that were in the middle? Yeah, that's a medial moraine, right? So our W here is looking at a medial moraine. All right, what do we call the glaciers, the moraines in front of the glaciers? We call those end moraines, right? So look at Glacier B here. T, since you only have one, you're rather safe calling this an end moraine, okay? There's just one. You don't have to worry about whether the glacier's melting or growing. It's just a moraine in front of the glacier, so boom, it's an end moraine. Glacier A, however, has two. So when there's multiple end moraines, we told you we had a special word for the very front. That was called, right, a terminal moraine. So S is our terminal moraine. What do we call the word for any moraine behind the terminal moraine? Yep, a recessional moraine. Good. And lastly, we see this riffraff of stuff. It just looks like a spraying here of stuff. What do we call that thin sheet-like? Yeah, ground moraine. Okay? So lateral, medial, lateral, end, terminal, ground, recessional. Got it? Good. So, questions, application level questions. What is Glacier A doing? Receding or growing? Yep, it's receding. We can assume that because there are recessional moraines. Now, could the weather change and boom, it plows right over this? Yes, but in this one snapshot of a moment that we have looking at right here, this glacier is receding. How about Glacier B? Receding, growing, or can't tell? Yeah, can't tell. it appears to be receding. Okay, it appears to be receding. It's left a glacier here. A glacier. It's left a moraine here. All right, but again, who knows what it can do tomorrow. But at the moment, you don't have enough data to judge. More than likely it is receding because this one is. But this one you definitely have evidence that it's receding. My goodness, this is an old diagram. All right. Boy, that doesn't look anything like I led you to believe, does it? No, these are horrible pictures. This is a better one. Right here. What is that? It's a lateral moraine. All right. All right, there's a lateral moraine. This is actually, and I wish these were dated. They're not dated. And whenever I was using McGraw-Hill textbook, I probably, the dates were probably, this was 20 years later, 50 years later, 5 years later, whatever. So what we're looking at, and you can see it's even more morainey now here. We're looking at the change from time A. I don't even know where this is. Time A to time B. It's interesting, you can see the beginning. There's my mouse. The beginning of what's going to be a big melt pool right there. Pretty cool. So just a receding glacier, but I like it more so because you get the nice picture of a moraine there. Goodness gracious, and we're up to our 12-minute mark again already. There's some really good views of moraines. You got your U-shaped. Boy, you can't get more U than that, right? And then as it came out, it melted off to the side. And we're going to have a word for this kind of stream, if that indeed is a stream there, in a couple minutes. So yeah, nice moraines there. When I lived in Ohio, just over the border in PA there, we had a place called Moraine State Park. I remember going there as a kid, and I think it was very hilly, but the implication is that these were long, narrow hills. And again, that's hard to get an appreciation of when you're on the ground. But from an aerial view, I bet it looked quite different. And again, it's Pennsylvania. It's vegetated as heck, so it's going to be even harder to see the topography. But the folks that set it aside as a state park, pretty sure it was a state park, recognized the historical significance of it as the glacial melt back in the day. And here's the word for all what I've been talking about for the last 20 minutes, till. Okay, that's this sediment that washes out at the out of a glacier. Till. It's unsorted. As you can imagine, at the front of a glacier, there's meltwaters, and you hopefully remember or know that flowing water sorts sediment. So at some point it will get sorted out, at least the stuff in the way front. But these moraines and everything else, this sediment that we've been talking about that gets transported, just another vocabulary word for you here, is called till. All right, I gave you this word already, erratic, a little while ago. That's those giant boulders that were plucked out somewhere upstream. And I remember, again, my teachers talking about granite, okay? And a lot of these giant boulders are granite. There's no granite down here, especially in Ohio. Ohio is all limestone. New York's mostly limestone as well. But you've got these giant granite boulders, just laying around everywhere. They were plucked out up in Canada, okay? A lot of Canada, you've got granite at the surface. And it was broken off by these monstrous glaciers, carried along for hundreds, if not thousands of miles, and plopped down in Ohio and Pennsylvania and New York. So glacial erratic, giant boulders. Alrighty. So now we're down at the front of the glacier. We just mentioned to you that oftentimes you'll see a lot of streams, okay, and those meltwaters out in front. And well, here we are. You see some moraines, these ridges of sediment that were piled up in front of the glacier. They remain unsorted till, right? But as these streams come through here, those are going to sort whatever it grabs. A couple vocabulary words, just some foreshadowing here. Drumlins, okay, eskers, and kettle lakes. Drumlins, eskers, and kettle lakes. We're going to learn about all three of those. Drumlin. A drumlin is formed when a glacier plows over a moraine. What it does is it shapes it. Look right here. All right. It shapes the, it used to be like this, and it plowed over there, and it shapes it in, well, they call it a drumlin because it's supposed to remind you of a drumstick, okay? Chicken wing. But the leg part, not the other side. And what's neat about them is the way they always form, and this is how they can tell that it is glacially formed, is it has a gentle downstream slope and a steep upstream slope. All right. So if you're looking uphill towards the glacier, it should be you're on the steep side. If you're looking, if you're standing in front of the glacier, looking in front of it, all right, you're going to see that gentle slope. And then, more so, these things point in the direction of the glacier's flow. An idea what's going on here. I've been told that off of Route 81 South, coming out of Syracuse, you get down far enough, you've got fields of drumlins there. And again, you know, with so much vegetation there, and from being on the ground, and since I'm usually driving, moving 65 miles an hour, it's hard to look out the window and say, oh, hey, there's a drumlin. But I'd have to imagine if you were flying maybe out of Syracuse Airport and you happen to look out the window and you look down on these, that you might just see, here's a topographic map view of it, you know, it's just this field, if you would, of these elongated hills. And they'd all kind of be pointing in a particular direction. You see how these are all sloped this way? All right, and that tells us that the glacier was flowing in that direction. Pretty cool. An esker. An esker is formed underneath a glacier. It's a ridge of sediment, snake-like, okay? Kind of esker sounds sort of snake-like, maybe. It's a mound of sediment left behind as a melt stream flows underneath a glacier. Right here. All right. Meandering ridges of sorted sediments formed under a glacier from meltwater. Oh yeah, these are sorted. I don't get that specific in the questions asking you what sediment is sorted and what isn't, but so there you would see when this one happens to be bisecting a moraine, and the implication is the glacier started here. You see this sort of braiding thing, braided streams, which are a whole bunch of thin, narrow streamlets, if you'll allow me to make up a word like streamlet, little streams, because there's just so gosh darn much sediment. Again, was in this first picture, okay, whole bunch of little stream channels that intersect and braid around each other, hence the name braided stream. So we see one of those forming here. So the glacier was here. This wall of sediment formed. here, and have to imagine that's why these braided streams get so choked up, because this stuff is washing into it. So the outwash, I don't think I mentioned that word before. Outwash plain is what I remember. It's just the area in front of the glacier, and here it just looks like a wasteland. But it is the area in front of the glacier where all the sediment is guess what, washing out, right? I could use big complicated words if you want, but outwash is where stuff is washing out. And sorting out and whatnot. It's just the area of wasteland in front of the glacier, okay? We're going to see all kinds of things here, again, assuming the glacier used to go a good bit further, and it's receded back into the picture here over time. So one of the last words we haven't talked about yet is Kettle Lake. If you spend any time on over by Cape Cod, a lot of the inland ponds are old kettle lakes. What happens, I remember the word calving, okay, as icebergs are forming, giant chunks of ice falling off the glacier. Well, what happens is some of these things are so massive that when they fall off, thunk, they carve a giant hole in the ground. And as long as there's enough, water in the area, groundwater in the area, they make these big, deep little lakes, okay? And that's a kettle lake. It's called a kettle because it's fairly round and deep, steep-sided, if you would. And you'll see kettle lakes just marking all over the surface. And as I said, 10,000 years later, they're still around in a lot of places. Glacial grooves, these were always kind of cool. We had a lot of these in Ohio. I've not seen any yet in New York State since I've been here. They've got to be. But I haven't seen any New York ones. Sadly and irresponsibly, I did not write down where these came from, this picture that I grabbed probably off the internet. But you see these lines here. Glacial grooves are basically the glacial equivalent of a key job. All right, now you've heard of that. Hopefully you've never done that. Somebody takes their keys and runs down along the side of your car and leaves a nice little gash in the paint job. Well, glaciers do that. We told you they pick up sediment all along and so on and so forth. Well, they can have giant rocks sticking out of the side of them, and when they slide over or alongside of solid rock, well, they give that a key job. These are the ones I first saw, and then I found many others. This, again, is not my photo, but I've been to Kelly's Island. It's an island up in Lake Erie, and not too far off the mainland, over by Sandusky, if you've ever heard of Cedar Point, big amusement park over there. You got the South Bass Islands and Kelly's Island. It's a nice little cluster. Well, when they were doing whatever they were doing to Kelly's Island, it's not too horribly developed, mostly wineries and tourist spots, but when they were developing over there, somebody recognized the significance of these things, and they made a little park out of it. It's hard to tell in this picture, but these are about the size of a toboggan run. If you don't know how big that is, just picture the biggest sled you've ever been on, and you could definitely slide right down there. Now, unfortunately, they left maybe a 50 or 100-foot stretch of these, not a whole lot, okay? So it would be a short ride. But just an idea, okay, of as the glaciers were sliding through here, just imagine the size of the rocks that would have had to been sticking out of the bottom, and as it just carved right through. And like I said, glacial grooves can be very small as well. The smaller they are, of course, the harder they are to recognize and subsequently to preserve. So, but neat little thing. Okay, did have a slide for calving. Good. So we told you several times now that calving is the act of a iceberg breaking off of a glacier. I don't talk about these, but drop stone. If this would somehow get preserved in the rock record, you might find this scattered field of random stones. glacial ice, as we told you, is chock full of sediment. Well, as these icebergs melt away in the water, the rocks fall out of them, and they leave these cool little pock marks all over the place. I didn't add that as a vocabulary word for you guys, though. But calving is. My favorite, fjord. I just like to say fjord, I think, but fjords are very pretty. What is a fjord? It's an inundated glacial valley. What the hell does that mean? Inundated means flooded, okay? And what we need to remember, see, I told you they were pretty. What we need to remember is that, going back to our conversation of the water cycle, right? There's only so much water on the planet. And if you're going to freeze up enough water to make a wall of ice from the North Pole to New York State, that water's got to come from somewhere. And where it comes from is the oceans. And what that means is during glacial times, sea level is significantly lower than it is during non-glacial times. You follow? So what happens is when these glaciers are coming down and carving these beautiful U-shaped valleys, they've got a lot longer road to go to get to the ocean than they normally would have. And then once they all melt, well, guess what? That water goes back into the oceans and they inundate or flood these valleys. So this is probably quite deep and steep right through here. Back in the days of warring armies and whatnot, these were great places to try and sneak in to cities and countries. These were places to heavily protect if you lived here. But right now, in terms of relative peace and quiet in the world where we are, they're just beautiful places where cruise ships can come in and out of. Fjord. All right, I only have a few slides left, so I'm going to let this timer run through, even though we're at the 12-minute mark here. Talked a handful of times about the last glaciation here, the last ice age, and just to give you your bearings here, this isn't the most, they didn't choose the best colors here. Here's your Great Lakes, okay, and these red lines here, those are your glacial margins there, your end moraines. There's the word I was looking for. Okay, just to give you an idea where this all went through. You see some old lakes here. You see Great Salt Lake. Just Lake Bonneville. There's the one I was looking for. Okay. Salt Lake in Utah is just a remnant of ancient Lake Bonneville, which is right here. There's lots of stories, if you're interested, about these ice dams breaking free and carving some of the landscape that's over here. Just amazing. If you could picture, again, these mile-high walls of ice, when they start to melt out, if some of that water were to build up and then that natural dam, a chunk of ice maybe blocking up a valley, suddenly breaks free, the amount of water that would rush out, just mind-boggling. So some amazing stuff. Here's potentially a much better view for you. Here's America over here. If you're from another country, you might want to look over to this side of the world, get your bearings. But my geography is not that good to tell you what countries we're hitting there. But over here, again, here's your Great Lakes for perspective. And this black line is showing you roughly where sea level would have been. I've told you a handful of times that sea level was lower. I wasn't kidding, okay? So there's that. The Finger Lakes. Around here, you guys all know and love these things. They're very pretty, don't get me wrong. But I only heard of them growing up in Ohio and taking my geology classes as those big long lakes in New York State that were carved out by the glaciers. What they were before the glaciers were streams, okay? And the glaciers came through and carved them out very, very deep. Um, and then somehow through sedimentation and whatnot, they basically blocked off, sedimented up. There you go, freely conjugating again. Sedimented up the area behind it, essentially turning them into lakes, cutting them off from the larger lakes up here. And you're left with these again because we have so much precipitation in this area year round. They've kept plenty full. Here's your two biggest, of course. But we're left with these nice, long, deep lakes that you guys, like I said, that they call the Finger Lakes. Not you guys, but. All right. And just to bring home that idea that all this is sort of connected, we've got our Ice Age coastline, right? And we've given you the idea in your head. I've planted that seed about how when we take all the water, we need so much water to build these glaciers to come from all the way up here to all the way down there, and that lowered sea level, right? Well, now we want to look at this slightly different color of blue because what we want to do now is talk about if what's left of the ice continues to melt. All right. And this isn't political, this isn't democratic, this isn't Republican, this isn't religious or not religious, this is just science. Okay, you had no problem hopefully believing me when I told you we had to take the water out of the oceans to make the glaciers. So when we melt what's left of the ice, this is your new predicted shoreline. For reference, this black line is the current shoreline. Surely you recognize Florida, Virginia, whatnot, okay? Here's your new shoreline. They're not kidding. They're not making this crap up. It's just math. It's geography, topography, whatever you want to call it. You look at the lay of the land, how high it is, how high it isn't. Go over here, look over here too. Most of you don't care about this part of the world because you don't live over there, but maybe you've got relatives. All right, but we live over here. Well, we don't live over here. We live over here. So, shorter ride to the beach? Yeah, maybe. Cape Cod's gone. My favorite beach is gone. Mickey Mouse is gone. So, and again, how do we know this stuff? Well, I gave you a handful of reasons. But looking back, okay, those of you that were on campus, there's a poster outside my lab room that says, I'm embarrassing myself, I forget how many years ago. New York State was underwater, and that's how we have all these aquatic marine fossils in New York State, right? It wasn't that the water came up this way. Right here, okay, was a giant inland sea. And again, how do we know that? Because it's covered with limestone full of seashell fossils. The mountain here, okay, the Appalachians, up into the Adirondacks, that was a barrier on this end. So all the way up through here where they have it now, this is already flooded once. So, it's no surprise that it's going to do this. I'm surprised that they don't have it going further, personally. But anyhow, I don't want to harp on that, but it just bothers me when I hear people, debating this. Well, we don't really know. We got a pretty dang good idea. Okay, so what have we been talking about? What we were talking about is a time called the Pleistocene. Pleistocene. And the Pleistocene is our most recent ice age. When somebody says the ice age, that's probably what they were talking about. There were many, many more, okay? All the way back to Snowball Earth. Again, Google it if you're interested. But the most recent ice age, the one that you're seeing remnants of, the one that carved the Finger Lakes, the ones that left the Drumlins off of 81 South, that was the Pleistocene. And it started about just under 2 million years ago, okay? And this is horribly specific, 11,700 years ago. It depends. Well, that is the Pleistocene. But when we want to talk about the glaciers leaving, they tell you roughly 10 to 12,000 years ago. Depends how far south you were. I've even heard 15,000. But nonetheless, okay. And what did it look like? Well, we can picture. We see ice. We see areas that are all iced up now. The critters we have fossils of. We know what kind of critters were around then. Okay. So it's portrayed in the movies. Well, Ice Age, you know, is what it is. My family's favorite is the little squirrel that chases the acorn around. But you know, there's the woolly mammoth and the saber tooth and all of that, and it gives you a decent idea what things were like. And yeah, there were humans around then. Okay, most definitely, most definitely. They were south of the glaciers, but there were some folks, undoubtedly, that were up, you know, northerly and interacted in that area. This is an area, obviously, south of the glaciers. The Cenozoic is a larger time period, okay? This is an epoch. Cenozoic is an era. Your eras are Cenozoic, Mesozoic, Paleozoic. They're larger groupings of time. But Cenozoic is what we're currently in, and it goes back about 65 million years. When the dinosaurs went extinct is when the Cenozoic kicked in. It was the age of the mammals. And as you probably know, if you've been to any museums, okay, mammals used to be a lot bigger than they are, I should say. And they had a lot more diversity, and they were spread out a lot more. We don't have any giant sloths anymore as far as diversity goes. We don't have giraffes and zebras and all kinds of crazy critters that used to live in the Midwest, okay, believe it or not. That's where the fossils I worked on for my master's came from, were Nebraska. The diversity of critters that lived after that, after the glaciers melted, was amazing, amazing. But times changed, weather changed, people hunted, so on and so forth, and with that, the critters change. We're currently in the Holocene epoch. Okay, post-glacial, and this is when truly modern humans came about. We're not going to get into the anthropology of this aspect. If you dig that kind of stuff, MV offers anthropology, talks about humans over time. Okay, but what you would recognize is truly modern human, Homo sapien sapien. We're subspecies of Homo sapien. It's about 12,000 years. Homo sapien goes back a little over 2 million years. But our subspecies kind of evolved along with the changing, as you'll often see, we evolved along with the changing climates. So, and we're in the Holocene epoch until further notice. All right, so that is the end of the slideshow. As always, there's probably some stuff you came across in your book that I didn't talk about. If you have any questions or whatnot, please feel free to ask. And I'm actually going to probably assign a little bit of some video from a retired professor up at Oswego University. Made a kind of neat but also kind of long video about the glaciers in this area. It's been subsequently split up into segments on YouTube, which is nice because it allows me to, you know, just assign bits and pieces of it. But look for something along those lines coming your way, and take a couple minutes and watch them. It's neat stuff. Bye-bye.